Imagine that one country extracted over 15 million cubic meters of sand and soil from the ocean depths, and then used all this material to create new territory right among the ocean waves. This might sound like science fiction, but these are real achievements of modern Israel. Today, we will learn why Israeli authorities decided to reclaim over 100 hectares of land from the Mediterranean Sea, and what connection this has to trade routes on the other side of the world. Don't forget to subscribe to the channel, it's going to be interesting. Israel has always stood out for its ability to work effectively with limited resources, turning this into a true art form. Lifeless deserts become fertile agricultural lands. Desalinated water from the sea flows into every home, and advanced drip irrigation technologies are sold to countries around the world. However, the most impressive engineering projects of this compact Mediterranean country are not being implemented on land, but in ocean waters. It is off the coast of Haifa that something is happening that can truly be called a genuine engineering revolution. And all this is being done for a single purpose: to make trade with Asian countries faster, more economical, and more efficient. To understand the scale of what is happening, we need to turn to events from several decades ago. In the early 2000s, Israel faced serious difficulties. Trade relations with Asian states were intensifying every year. Containers from China, Japan, and South Korea were arriving more and more frequently. Goods from Asia already made up approximately 25% of the country's total import volume. Electronics, textiles, and industrial equipment needed to be received and unloaded somewhere. That is when real difficulties began for Israeli logistics specialists and port operators. At first glance, the port of Eilat, located on the shore of the Red Sea, was ideally suited for receiving cargo from Asia. From a geographical standpoint, this was the most convenient option. Vessels from Shanghai or Singapore would travel thousands of kilometers, pass through the Suez Canal, then enter the Red Sea and immediately dock at Eilat. Minimum distance, minimum travel time, and maximum efficiency. That is how it looked in theory. However, in practice, the situation turned out to be significantly more complex. The port of Eilat simply did not have the physical capacity to receive modern, enormous container ships that have become the standard for global maritime trade. Modern post-Panamax class vessels are capable of transporting up to 15,000 20-foot containers per voyage. Their draft, that is, the depth of immersion in water, can reach 15 meters. Meanwhile, the depth at Eilat's docks was only about 10 meters. Simple mathematics showed that such a vessel would simply run aground. It would have been possible to deepen the bottom and modernize the port to receive these giant ships. However, this is where a whole series of other difficulties arose, each of which could independently put an end to the entire project. The first and most serious problem was connected with the unique coral reefs of the Gulf of Aqaba. This is one of the northernmost coral systems on the planet, a true wonder of nature. Hundreds of species of fish, mollusks, and crustaceans inhabit these waters, forming amazing biological diversity. Any large-scale work to deepen the seabed would mean complete destruction of this fragile ecosystem. Earth-moving machines would raise tons of silt and mud from the bottom, which would then settle on the corals and literally destroy them. Changes in ocean currents would disrupt the balance that had been forming for thousands of years. Environmental organisations were categorically opposed to such modernisation. But even if an agreement could be reached with nature defenders, the second problem of an economic nature remained. The coast of Eilat had long since turned into a tourist centre. Hotels, diving centres, restaurants, the entire local economy was tied to the tourism industry. Imagine vacationers who, instead of azure waves and coral reefs, would see from their room windows earth-moving machines, construction barges, and giant container ships unloading right next to the beach. The number of tourists would inevitably decrease, and with it, the income of local businesses. The third problem was connected with the geographical features of Israel itself. Eilat is located in the very south of the country, while the main cities, Tel Aviv, Jerusalem, and Haifa, are located more than 250 kilometers to the north. And this is where it gets most interesting. There is no rail connection at all between Eilat and the central regions of the country. All cargo would have to be transported by truck through the Negev desert to the nearest railway station in Beersheba. This would take a lot of time, cost a lot, and be extremely inefficient. Each extra kilometre on wheels increased the final cost of goods for the consumer. Of course, it would have been possible to build a railway, but this would require enormous financial investments for laying tracks through desert areas. Israeli authorities faced a difficult choice. They could continue using Eilat in its current state, limiting themselves to small vessels, but then the country would lose competitiveness in global trade. They could invest billions in its modernization, but the effectiveness of such a decision remained a big question. And then a bold solution was born: to abandon Eilat as the main gateway for Asian cargo and concentrate efforts on Mediterranean seaports. Yes, the route from Asia to the Mediterranean was longer, but if modern infrastructure could be created there, the gain would be enormous. The choice fell on Haifa, the largest port city in the north of the country. Here were all the advantages: proximity to the main economic centres, a developed transport network, rail connections and highways. All that remained was to turn a good port into an outstanding one. In 2005, the first stage of grandiose modernisation began. Construction of the Carmel terminal started. The project looked ambitious even by the standards of a country accustomed to large-scale engineering achievements. First of all, it was necessary to solve the problem with depth. Specialised vessels, dredgers and suction dredgers approached the shores of Haifa. These giant machines began methodically extracting sand, silt and solid rock from the bottom of the Mediterranean Sea. Day after day, week after week, the dredgers lowered their buckets to the seabed. Multi-bucket dredgers worked like giant excavators, only underwater. A continuous chain of buckets moved in a circle, scraping soil from the bottom and lifting it to the surface. Then, this material was transferred to barges, which took it to specially designated places. In parallel, self-propelled suction dredgers worked, a more modern type of equipment. They were equipped with powerful pumps and long suction pipes, which literally pulled a mixture of soil and water from the bottom. This mixture was pumped into the holds of vessels, which then independently went for unloading. In total, 2.5 million cubic meters of material were extracted from the bottom to create the Carmel terminal. To imagine this volume, picture a cube with a side of 135 meters, completely filled with sand and silt. An impressive sight, is it not? But extracting the soil was only half the task. Then the most interesting part began. The Israelis decided to use all this material to create artificial land, right in ocean waters. A plot with an area of 225,000 square meters had to be reclaimed from the waves. First, the selected area was enclosed with protective metal walls, which were driven deep into the seabed. These walls formed a kind of giant pool, inside which it was possible to work without fear that ocean currents would erode the embankment ahead of time. Then painstaking work on backfilling began. The material was laid in layers, each of which was carefully compacted with heavy equipment. A layer of sand, compaction, then another layer and compaction again. This process was repeated many times until the embankment level reached the required height. Drainage systems were laid inside the embankment, an entire network of channels and pipes through which water could drain. This is critically important because without drainage, the soil would remain moist and mobile, which would lead to subsidence and destruction of all constructed structures. When the artificial land reached the required density, foundation construction began. Deep pits were dug, into which massive concrete slabs were poured. These slabs had to withstand the incredible weight of port cranes and constant loads from container operations. On the prepared territory, berth walls with a total length of 950 metres rose up. 700 metres made up the main berth, another 250 metres were allocated for an auxiliary one. 6 modern heavy cranes were installed along the berths. These cranes were true giants of the port industry. Their booms rose above the water for dozens of metres, allowing containers to be unloaded even from the largest vessels. In addition, 12 electric stackers, automated cranes for working with containers in storage areas, were installed on the terminal territory. The Carmel terminal opened in 2010 and immediately demonstrated its effectiveness. The depth at the berths reached 15.5 metres, which allowed receiving post-Panamax class vessels with a capacity of up to 15,520-foot containers. But the Israelis did not stop there. Construction of the Carmel had barely finished when preparation for an even more ambitious project began. In 2015, construction of the Bayport terminal started, which was supposed to surpass everything that had been done before. This time, the scale of work exceeded all expectations. Dredgers and suction dredgers again approached the shores of Haifa, but now they had to extract from the bottom not 2.5, but a full 15 million cubic metres of soil. This is 6 times more than for Carmel. Imagine a cube with a side of 247 metres completely filled with ocean sand and silt. Or picture all this material loaded into trucks. Then the column would stretch for hundreds of kilometres. That is how much soil was extracted from the bottom of the Mediterranean Sea. Work was conducted around the clock. Dredgers and suction dredgers operated in several shifts. The seabed gradually deepened, reaching 17.5 metres. This depth was critically important because Bayport was designed to receive ultra-large container ships of the ULCV class. These giant vessels are capable of transporting up to 18,000 20-foot containers per voyage. Their length exceeds 400 metres and their draft reaches 16 metres. Without sufficient depth, such ships simply could not approach the berth. Of the 15 million cubic metres of extracted soil, 5 million were taken and laid in another place on the seabed, where they did not interfere with shipping. And the remaining 10 million cubic metres were used to create another artificial island, with an area of 84 hectares. The technology for creating this artificial land was improved compared to Carmel. Along the perimeter of the future island, powerful metal walls were driven in, creating reliable protection from ocean waves and currents. Then temporary partitions were erected inside this space. These partitions divided the huge area into separate sections, which were filled in turn. This allowed better control of the soil settling process and ensured uniform compaction throughout the territory. Each section was filled in layers with careful tamping. Heavy rollers and vibrating plates methodically passed over each layer, squeezing water and air out of the sand, turning loose mass into a dense foundation. Drainage systems work continuously, draining water and accelerating the soil compaction process. When the embankment reached the design height and required density, construction of massive foundations began. Huge concrete slabs and grillages were poured, which had to withstand the weight of giant port cranes and constant dynamic loads from their work. On the artificial island, berth walls rose up, capable of receiving the largest vessels in the world. Along the berths, super-modern cranes were installed, some of the largest and most powerful in the global port industry. Their lifting capacity and work speed were astounding. These cranes could process several dozen containers per hour from one vessel, which radically reduced dwell time. And time means money in the world of maritime logistics. Each extra hour of a vessel's stay in port cost ship owners thousands of dollars. Behind the berths, extensive container yards spread out, equipped with automated stackers. These robotic cranes worked according to a set program, independently moving, sorting, and stacking containers. Human intervention was required to a minimum. An automated entry gate system for trucks was created. Special cameras read license plates, electronics checks documents, barriers opened automatically. Queues and traffic jams were avoided thanks to the high speed of processing each vehicle. An extensive road network was built inside the terminal, which was directly connected to national highways. New railway tracks were laid, linked to the national network. Now containers could leave the port both by truck and by train. Modern administrative buildings, technical structures, and electrical substations were erected. The entire terminal received enough energy to operate all equipment, from giant cranes to lighting systems and climate control in office spaces. But even with all this grandeur, one problem remained. The sea constantly attacks any structures created by man. Waves, currents, and storms slowly but surely destroy concrete and metal. The artificial island and berths needed protection. And the Israelis created another large-scale project within a project, a system of breakwaters that became a true engineering marvel. The existing main breakwater was extended by 882 meters. But this was not enough for full protection of the new terminal. An auxiliary breakwater with a length of 2 kilometers 100 meters was built. Its construction included embankment elements from large stones and sections from reinforced concrete caissons. These caissons were manufactured on shore, then launched into the water and towed to the installation site. On site, the caissons were filled with sand and concrete, after which they were lowered to the seabed, where they stood like giant blocks, forming an insurmountable wall for waves. Additional layers of large stones were laid on top of these caissons to strengthen the structure. In total, about 43,300 protective concrete elements of various sizes and weights were used for the construction of breakwaters, plus 5,300,000 tons of stone. These figures speak for themselves about the scale of protective structures. Breakwaters work like giant shields, taking the blows of waves and dissipating their energy. Of course, they gradually deteriorate, but this is built into the design. It is better to repair breakwaters than to restore berths and cranes after each serious storm. Besides protection from waves, breakwaters perform another important function. They protect the port water area from sediment. Ocean currents constantly carry silt and sand, which could settle on the bottom and reduce depth. Breakwaters slow down currents, forcing sediment to settle outside the port. Bayport opened and immediately became the jewel of Israeli port infrastructure. Together with Carmel, it turned Haifa into one of the most modern and efficient ports of the Eastern Mediterranean. Throughput capacity reached 1.5 million 20-foot containers per year. Of course, this is far from global giants like Shanghai, which processes 47 million containers annually. But for relatively small Israel, this is a colossal achievement. And most importantly, now the country could receive the largest container ships on the planet. The ability to receive ultra-large vessels provided enormous savings for all participants in trade. Instead of sending 2 or 3 smaller vessels, it was possible to load one giant container ship. Costs for fuel, crew salaries, and port fees dropped sharply. This savings was reflected in the final cost of goods. Electronics from China, textiles from Vietnam, and industrial equipment from South Korea became cheaper for Israeli consumers and companies thanks to efficient logistics. But the benefits were not only for Israel itself. Haifa turned into an important transit hub for the entire region. Cargo from Asia was now unloaded in Haifa and then redistributed to smaller vessels for delivery to other Mediterranean ports. Greece, Cyprus, Egypt, and even some ports in Turkey began receiving Asian goods through Haifa. In 2012, the giant container ship MSC Golden Gate arrived at the port. During its stay, about 1,600 container loading and unloading operations were conducted. Processing productivity reached 191 containers per 60 minutes, which was considered an impressive result for that period. Among the unloaded cargo was a large shipment destined for the Egyptian port of Alexandria. Thus, Haifa gained the status of a main hub for Asian goods entering the eastern part of the Mediterranean. Such status provided not just a prestigious name, but also tangible financial benefits. Each unit of cargo processed in the port brought fees for service, payment for transshipment, and profit from additional services. The regional economy received a serious boost to growth. The introduction of automated systems and advanced technical equipment at the new terminals radically reduced the duration of ship processing. In the past, a cargo vessel could stand idle at the berth for several days. Now, the entire process took no more than 24 hours, and sometimes even faster. The reduction in downtime directly affected the decrease in financial losses for each link in the trade chain. Asian manufacturers receive payments for their products in shorter timeframes. Importers in Israel and neighbouring states more quickly became owners of ordered goods, and buyers sooner discovered new goods in retail outlets. The modernisation of port facilities brought the Israeli economy the appearance of thousands of new vacancies. Crane operators, coordinators, truck drivers, logistics specialists, warehouse employees, equipment repairmen, computer systems professionals found employment opportunities. In parallel, related industries grew, including the transportation business, logistics organisations, the warehousing sector, repair service centres, and insurance firms working with maritime cargo. This entire structure generated business activity and economic prosperity. The northern part of the state, where Haifa is located, gained significant momentum for development. The settlement strengthened its position as an industrial and commercial hub, attracting capital investments and highly qualified workers. The imbalance between developed centres and outlying areas began to gradually smooth out. Interestingly, in the early 2000s, a completely different concept was being considered, one that could radically change the situation. Remember the difficulties of Eilat? During that period, Israeli specialists were thinking, maybe it is not worth improving the existing port, but better to build a completely new one. A concept appeared that received the name Southern Gateway. The idea was truly revolutionary. To move the port facilities of Eilat inland to the north, approximately 4.5 kilometers from the settlement. The new complex was supposed to be erected in a pre-prepared desert zone. Connection with the Gulf of Aqaba was planned to be organised by means of an artificial canal with a length of 4,000 metres and a width of approximately 100 metres. This waterway was supposed to cross desert lands, giving vessels the opportunity to reach the new port remote from the resort zone and valuable reefs. The positive side seemed indisputable. The resort territory would be completely freed from cargo operations. Beach zones and hotel complexes would cease to border commercial vessels. Coral ecosystems would be preserved in pristine condition, since the canal would be laid where nature was more resistant to impact. The fresh port opened the possibility of construction on an empty place, applying advanced technologies and optimal planning. There would be no need to adapt to existing development and limits of an outdated port. At first glance, this represented a perfect solution to all difficulties. Nevertheless, the concept remained only in documents. The main and key reason consisted in the fantastically high price of implementation. Specialists assessed the necessary expenses at a sum exceeding $3 billion American. Creating a 4-kilometre waterway through waterless lands, erecting a port complex on an empty place, and forming all the required infrastructure presupposed grandiose financial infusions. However, not only finances became the decisive barrier, lack of support from political circles finally closed the Southern Gateway project. Different political groups did not reach agreement, important directions changed, the concept was postponed, and ultimately was completely stopped. Probably, if the Southern Gateway project had been implemented, the development of Israeli port facilities would have gone a completely different path. Eilat would have turned into advanced gates of Asian commerce, whereas Haifa would have retained significance, but not a dominant role in the port system of the state. However, reality chose another scenario. It was Haifa that became the recipient of large capital investments and technical re-equipment, transforming into the main jewel of Israeli maritime gates. Eilat retained significance for certain categories of cargo flows, but lost the opportunity to occupy the position of the main maritime hub of the country. The experience of transforming the Haifa port demonstrates the critical importance of long-term planning and determination to take on grandiose undertakings. Israeli specialists were not frightened by the task of extracting from ocean depths nearly 18 million cubic meters of bottom material, forming over 100 hectares of artificial territory and constructing extensive protective structures. Such investments repeatedly justified themselves. The advanced port system provided the state with winning positions in global commerce, reduced prices on imported products, generated thousands of labour positions, and gave impetus to the progress of an extensive region. In our time, observing how colossal container vessels approach the berth walls of Bayport and Carmel, how robotic lifting mechanisms transfer thousands of cargo units, how railway compositions and automotive columns distribute goods throughout the territory of the state, few realise that all this infrastructure is erected on artificial land, seized from ocean elements. Thus, we have traced how a relatively small state coped with a monumental task, turning geographical limits into an engineering triumph. Israel raised from Mediterranean waters millions of tons of bottom deposits, formed artificial territories, built ultra-modern terminal complexes, and demonstrated that the presence of political will and financial resources allows transforming geography itself to one's benefit. If this narrative about humanity's transformation of the planet sparked your interest, definitely become channel subscribers and leave positive marks. And in the comments section, share your opinion. What other large-scale engineering achievements produced the greatest impression on you?